All right, so guys, we're continuing with chapter 3. This time we are now on section 3.4. And here we go. So we are going to use square roots to solve quadratic equations. So in the previous section, we were doing um, solving equations by factoring. This time we are going to be doing another strategy or another technique. So let's begin by looking at this get started question. When an object falls, it accelerates until the force of gravity is equal to the air resistance. Then the object has reached its terminal velocity right here. All right. When a hailstone falls, its approximate terminal velocity, v, all right, this little v represents terminal velocity in centimeters per second, is modeled by this equation. V squared is equal to 2 million d. That v is the terminal velocity in centimeters per second, while this d would be the diameter of the hailstone. The largest hailstone recorded in Canada had a diameter of approximately 10 centimeters and fell on August 27, 1973. Determine the approximate terminal velocity of this hailstone. So I already came up with a solution for this. I just typed it up. Anyway, it's really very easy. So I'll just go through it with you if that's fine. So really, the question can be simplified into if D is equal to 10 centimeters, what is V? That's all it is, all right? So you are going to be using this formula, and I think you can um, figure out that all you have to do is plug in the D value here, which is the 10, and then simplify this and then get the square root. You know what I mean? All right, so here we go. So V squared is equal to 2 million times D. So I plugged in the D here, as you can see. So V squared now is equal to 20 million. All right. And then what? As we solve for V, we have to take the square root of both sides. All right. Sorry that these two are together. Okay. So there should have been a space there. I'll just take care of that in class. Note, when you get the square root of both sides, V is equal to plus or minus the square root of 20 million. All right. It's not just positive 20 million. All right. It's plus or minus. However, now guys, so whatever that square root is, it's going to be 4472.1359. And of course, since for our purpose, velocity would be positive, so we're only going to take the positive square root. As well, there is no mention of how to round off, so we will round off to the whole number. So approximately, the answer would be 4,472 centimeters per second is the terminal velocity of the hailstone, and that's just an approximation or an estimate. Okay, so that is get started, and we'll go to check your understanding number 1. Solving quadratic equations by determining square roots. All right, so for this one, for number 1, you might be curious as to whether you can solve this by using factoring, and then we're going to be, you know, doing what we have done in the previous examples. All right. I don't know, but it's up to you if you want to try that. There probably is a way. I can think of one way, but I wouldn't want to do that right now because that is not what this section is all about. We will be solving this by determining the square root. So how does that work? So you will be getting the variable, all right, in this case, by itself. So that means we need to move this -7 to the other side. So take a look. 3x squared equals 15. Where did that come from? The -7 was multiplied, moved to the right side. And then get rid of that 3 by dividing everything by 3. Therefore, x squared is equal to 5. All right. Now, to get the value of x, we are going to get the square root. And once again, be careful. in here, x is equal to plus or minus 5. All right? Or square root of 5. Oops. Does that make sense? So the final answer is plus or minus square root of 5. Now, if you're thinking, all right, Mr. Aberrant, so is there a way to factor this? Well, I don't want to confuse you, but yes, there is a way. All right. I just wanted to show you, but if this part is sort of unclear to you, then just forget it. Just stick to what I have done over here, which is to um, isolate the x squared and then get the square root of both sides. Okay, so let's see if we are to factor this. Let's see if we can do that. So what I'm going to do is, again, I'm going to um, move everything this time to one side, all right? Because that's what factoring is all about, and then make it equal to 0. That means this 8 is going to be going to the left side. So I have 3x squared minus 15 equals 0, all right? I will again divide everything by 3, all right? Or factor out the 3, and then it will simplify to x squared minus 5 equals 0. Now you might be thinking, wait a minute, isn't that similar to what we just did? Actually, yes, if you think about it. Now, this one, if you're thinking, how can you factor that? Well, if you can recognize that as the difference of two squares, then you'll be okay. Wherein, if I'm going to factor it, this is what I'm going to have. X plus root of 5 and x minus root of 5. The factors of 5 would be plus or minus root of 5 equals 0. And following what we did in the earlier sections, each one would be made equal to 0. Therefore, x is equal to negative root of 5 and x equals positive root of 5, which is the same answer that we got if we are to compare it to how we did it earlier, all right? This is what we have now, plus or minus root of 5, while the shorter version was this one, same answer. You got it? Okay. So again, in this section, we're sticking to doing it by getting the square root. Okay. So let's go to the letter B. X plus 3 squared is equal to 20. So how do you solve this? Well, following what we did earlier, we are going to get the square root of both sides. Therefore, x plus 3 is equal to plus or minus root of 20. Now, some of you might be thinking, do I need to turn it into a mixed radical? It's really up to you, all right? Which is 2 root of 5 for this one. So to isolate x, move that 3 to the other side, and negative 3 plus or minus root of 20 is the final answer even in the book. For those of you who want an entire radical, that would be plus or minus 2, or for those of you who want a mixed radical, rather, that would be negative 3 plus or minus 2 root of 5. And that's the end of this one. Please do the practice question. Bye now.